Okay, so now you see behind me is a big circle with a lot of numbers on it. Well, imagine this is the spinner. So imagine, take out this paper that I sent home, and what we want to do, first things first, we want to count how many spaces there are on the spinner. So if we counted up all of these little pie pieces in the spinner, and of course they're supposed to be all drawn exactly the same size, and obviously they're not, but take that as a testament to my artistic ability. But anyway, so what we're going to do is we're going to count up how many pie pieces there are. And if we were to count all these up, we would realize that there are 16 pieces. Okay? Now again, I told you we're going to write all these as fractions. We're not going to write them as decimals. We're not going to write them as percents. We could turn them into percents. We've already done that. We could do that very easily, but we're not going to in this case, okay? So now if you look at the first question, it says, what is the probability of choosing an odd number? Okay, so again, this is not going to change. The only thing that's going to change is the number, there we go, is the number right here, okay? So what we have to do is we just need to count up how many odd numbers there are. So if we count the number of odd numbers, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of choosing an odd number or spinning the spinner and it landing on an odd number is 10 out of 16. It's pretty straightforward. There's no tricks to this, okay? So that's the key thing to finding probability. The first thing is, how many possible outcomes are there? This is how many outcomes there are, and this is the result. Okay? So now take a look at the second question. What is the probability of choosing an even number? Well, there's only two possible numbers out there. It's either even or odd. So knowing that we had 10 odd numbers and there are a total of 16 numbers in the whole shape, well, that tells me that for the second question, the probability of choosing an even number would be 6 out of 16. Okay? So this number didn't change. Okay? This number didn't change in this case. Now, these are called independent events. It means that we're spinning it every time. The total number of possible outcomes is the same. Nothing changes. Okay? Every time we do it, it's like a restart. It's like hitting restart on your video games. Okay? That Snake game or whatever, Cat Ninja, whatever you guys were playing. Okay? So it's like hitting restart, starting all over again. All right? So now, what is the probability of choosing a prime number? Okay. So in this case, we're going to use, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So in this case, we are not going to count 1 as a prime number. Okay? Remember, a prime number is a number that can only be divided by itself and 1. All right? And we're also going to, so again, we're not going to count 1 as a prime number. So these are our prime numbers. Okay? 5, 3, 5, 2. I know 2, it seems like it's an even number, but it can only be divided by itself and 1. We're not counting 1. We're going to count 2, 5, again, not counting 1, 3, 2, not counting 1, 4 can be divided by 2, right? So that's not a prime number. 5, 4, 1. So now let's count up how many numbers we got. Let's make sure we got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of you rolling or spinning and landing on a prime number is 9 out of 16. Okay? There are 9 prime numbers in this spinner. All right? The probability of choosing a 1 or a 5. Okay? So that's just counting up how many ones there are, how many fives there are, and that's the total probability of that occurring. So how many ones and fives do we have? Well, let's count the number of ones. We have 1, 2, 3, 4. 4 ones. Let's get some room here. So ones. Again, let's count again. 1, 2, 3, 4 ones. And how many fives? 1, 2, 3, 4. 4 fives, which means it's a total of 8 ones and fives. And again, that'll be 8 out of 16. Now you could reduce that down to 1/2, and eventually we will do that, but we're not going to worry about that right now, okay? I just want you to understand where these numbers are coming from, okay? And then the last question is choosing a 3 or a 4, okay? So now, what number did we not use? Well, we didn't use 2, okay? It was 1 and 5. Now we're going to deal with 3 and 4. So let's count how many 3s, how many 4s there are, and we'll put that total number out of 16. So now we have 3. Let's count them. 1, 2. 2 3s. And 4s, there are 1, 2, 3, 3 4s. So what gives us a total of 5? 5 out of 16. Okay? So if we were to spin the spinner 16 times, same number of spaces there are, in theory, theoretically, we would land on either 3 or 4, 5 or that of the 16 times. Okay? Now again, is that going to happen? No, of course not, because you're not going to spin the spinner the same amount with the same amount of force every time. You're not going to, there could be a little bit of breeze, whatever the case is. There's all kinds of different environmental effects on spinners and coins and dice and things like that. So you can't automatically know that this is going to definitely occur. But in theory, that's what should happen. Okay? So now we're going to move on to we're going to take it up a little bit of a notch. Okay? And we are going to be going to this paper. So as soon as independent and dependent events. Okay, so get that paper out in the next video. We're going to talk about that.